restate our properties of congruence. That's not how you spell properties. Properties of congruence. Now, they are not all the exact same as our properties of equality, but there is some overlap. And our overlap is really just stating that we were able to do it with an equal sign, and now we can do it with a congruent sign. Crazy, right? Okay, so first off, we have our reflexive property of congruence. I'm going to do POC for property of congruence. Does anyone remember from Friday what was our reflexive property telling us? If you need to flip back, look back at 2.6 part 1 of that glue in. Good, something that's equal to itself, but now we're going to say something that is congruent to itself. So like angle 2 is congruent to angle 2.
So remember reflexive, like with the reflection in your mirror?
What's happening? Okay, good. Reflection like the mirror. Who do you see in the mirror? You. All right, next we have our symmetric property of congruence. We're using that POC for property of congruence today. I know that that has another meaning, but today it's property of congruence. And what does symmetric mean again? Yeah, the both sides, we can switch it around that congruent sign. So if I know that segment AB is congruent to segment CD, then what new statement can I say based on that? If I flip it around that congruent sign. Good. Segment CD is congruent to segment AB. We use that word segment when we actually see that line above. So we can just switch it so they're on the opposite sides. Now, this is something that our brain's been doing since we were very little, that we know if this is the same as this. We could always say it backwards. Sometimes we feel like it's unnecessary, but in proofs it is necessary. It feels like it's an extra step, like duh, everyone knows that. Okay. And we have our last property of congruence here. It's not as much as there was for equality. Property of congruence is transitive. All right, and transitive says that if I have angle 5 is congruent to angle 8, and I know that angle 8 is congruent to angle 5, not angle 5, sorry, angle 4. I just needed another number, I couldn't think of one. So 5 is the same as 8, the angle names. Angle 8 is the same as angle 4. What do I know about all three of those angles? They're all the same because 5 is the same as 8, 8 is the same as 4. So we need to write a new statement, one that hasn't been stated yet. Which two have we not compared yet saying that they're the same? 5 to 4. Okay, if angle 5 is the same as angle 8 is congruent to angle 4, we really know that they are all the same. And because they're all the same, we can now come up with our new statement that we're missing out on. Damn it. All right. Now that's our properties of congruence that we might be using. We also might use properties of equality while we do geometric proofs. It's very confusing. There's lots of things happening here. Okay? But we also are going to use definition of congruence quite often. So I'm going to star this one. This one we use a lot. Definition of congruence. Okay, this one we use a whole bunch. But we have two different things that are congruent so far that we've been working with. One is segments. Let's sit here. That's fine. Jesus just decided to sit in a different seat. That's all right. All right, for segments, if I know that two segments are congruent, what does that tell us if two segments are congruent? What does that really tell us about their amounts? What's equal? The segments. When we say the segments are equal, what part of the segments are we measuring?
The midpoint?
Not the midpoint, the distance, right? That's all right. The distance. So the distance is equal. And this can go back and forth. If I know that the distance is equal, then I know that the segments are congruent. This is an if and only if statement. That biconditional can go both ways. So if I write that out in geometry terms here, if I know that AB is congruent to, let's say, MP, that's how we would write it, saying that they're congruent. We use that segment above. Then I know that their distance is equal. So how do I show distance of segment AB? For distance, we just do AB. We don't put that segment on top. And we're going to say that distance from A to B is equal to the distance from MP. And again, we can go back and forth with this definition of congruence. It's an if and only if statement. All right, we have one other type of things that we've been saying I don't know what I'm saying. My brain is not awake yet this morning. Another thing that we've been saying is congruent are angles. So if two angles are congruent, what does that really mean that the angles are congruent? They're the same length?
The same degree.
Good, same degree, the same measurement. Okay, the measures are equal. That would be if they're supplementary. When they're just congruent or complementary, or congruent, that doesn't mean they're complementary or supplementary. Your brain's thinking, though. They're like. So if I know that angle 3 is congruent to angle 4. In the next sentence, if I need to do something with an equal sign, right now I can't introduce an equal sign until I say, oh, congruent really means that they are equal. And what part of them are equal? The degree, the measurement. So to write that out, remember we use a lowercase m and then that angle 3. The measurement of angle 3 would be equal to the measurement of angle 4. All right, that one we use a lot, so I starred that one because we're going to come back to that one quite often. We use it in almost every geometric proof. Not quite. Are you laughing at me? You guys laughed and then Mubarak looked at me like, yeah, we're over here making fun of Miss Burrell. All right, last one before we start our actual proof is the midpoint theorem, which you already know. We're just going to rewrite it so that it's in these notes so that we can look back at it when we need it. All right, if we had T to B like we did in our warm-up, T to B, and K is the midpoint. So if K is the midpoint of segment TB,
What conclusion can you just get for this?
we came up with 5 conclusions earlier. Good. Can you say that a little bit louder? Good. Then TK is congruent to KB. The sides are the same. And that midpoint theorem uses that symbol congruent. That's going to come into play later on. So keep that in mind. My handwriting is really messy this morning. I apologize. Okay, and we can mark that with those congruent symbols there. Remember with those tick marks. You can do a tick mark there, tick mark here. Alright, we're going to be doing 2 proofs today in class, and you guys are like, oh my gosh, notes aren't done yet. No, they're not done yet. We have 2 proofs, and they're going to take us forever. Forever. How exciting. Alright, in your bins there are scissors. I put those out again. So I would recommend cutting this one. And when you cut it, you're going to, it's 2 problems. There's this top problem and this bottom problem. Okay, so when you get your sheet of paper, go ahead and cut that. Go ahead and cut that. There's only 3 scissors in your bin, so you do have to share them, but you're only making 1 cut, so it shouldn't take you too long. Now I'm going to go to the next page. Yeah, because you're on your phone, dude. You were? Alright. Did you pass one back? Thanks. Alright, so pass those scissors around. You're just cutting them right down that middle. It's 2 problems. There's a midpoint problem and then the angle problem. For this first one, it's 4 steps. So if you have room at the bottom of your page, you're going to need at least 5 lines, if not 6, because we'll have to glue it in also. Hey, Jane. Here you go. Thanks. Alright, so I recommend just going to the next page personally, because that's where I'm at in my life, but you do you. Alright, and eventually we will glue this in. We'll glue it in at the end because we might draw on it a little bit. So I'm going to glue mine in at the top of this page, like at the very, very tip top. And then I'm going to write below it. So we're going to do a proof. We call this a 2-column proof. Does anyone remember what a 2-column proof looks like? How many columns?
2.
What? 2? Crazy. So we have a 2-column proof. Columns are like our different sides. Does anyone remember what goes in this first side? Statement. Good, and that's our what. What are we saying as our new statement? And then on the other side is our reason, our why. Why are we allowed to say that? What rule or what property or what theorem tells us that that's okay to say?
Again, same like when you're playing Uno. Like same color, same number, color changing.
Instead of rules of Uno, we have rules of math, rules of geometry. All right, our statement. We're always going to start with our given, what the information is that we're starting with. And when you look at this conditional, it says if J is the midpoint of segment HK, so we know J is the midpoint, then HJ is 15 centimeters. So we have to start with the hypothesis. Our hypothesis is what we're going to always assume is true. So for step number 1, what is that hypothesis? What are we saying is true?
The midpoint of KR is... No, they're saying J
J is the midpoint
and
of what?
of JK,
HK.
HK.
HK. J is the midpoint of HK. That's our starting. What is our conclusion? What are we trying to end with? Good. HJ is 15. That will be our last step. We can't start with that. That's what they're trying to get to at the end. Okay, so we need a reason for this first step. How did we get that J was the midpoint of segment HK? It's given to us. Remember, it's like that starting card in Uno. When we had that starting card, did you get to go through the deck and pick out which one would be the best one for you? No, you just flip over the top. That's our if. It's just what we're starting with. It's given to us. We didn't come up with it. It was part of the problem. So now our next step, we have to connect it to step number 1. Ooh, I forgot one thing, though. There's another thing we're given in this picture. What else do we know?
15 centimeters.
What is 15 centimeters?
JK.
J to K. That's also a given. So I'm going to put that off to the side here. JK is 15 centimeters. So in a given, we have to remember that we can also look at the diagram to get more from our given. So all of that is my given. Okay, if you like drawing the lines across, you can do that. Some people find that excessive. You do whatever makes sense to you. Alright, so now we have to use something from that first step to come up with something from number 2, or something from our diagram to come up with number 2. So what's information from number 1 that we can use?
Since J is the midpoint of H to K,
Mm-hmm.
and JK is 15 centimeters, and J is the midpoint, we can assume that 15 centimeters is the same length. I mean, HJ is 15 centimeters.
You are so right. You just made like 3 steps into 1 step, though. Let's start with that word midpoint. You have it right. We just gotta now break it down into doable steps. So, what does midpoint mean again?
The middle.
The middle. Did we just come up with a midpoint theorem?
No.
What? We didn't just write a midpoint theorem? Yeah, what is our midpoint theorem saying? If we have a midpoint, then what? The two parts are congruent. So in number 2 here, if I know J is the midpoint, what two parts are going to be congruent?
H and J.
Segment HJ will be congruent to segment
J.
JK. And what told us that would happen?
J is the midpoint.
Midpoint. So we're going to use the midpoint theorem. Now, eventually, I want to get to an equal sign. And right now, I have a congruent sign. What does congruent really tell us?
That they're the same.
That they're the same. So in step number 3, let's write that for our reader. That, hey, that's what congruent means. That if segment HJ is congruent to JK, we know that H to J is really equal to J to K. That distance is the same. What part told us that in number 2? That they were equal. What part from number 2 told us we could write it as equal in number 3? That congruent symbol, right? That's what congruent means. So that's our definition of congruent segments. And I'm going to just not write out the whole thing because I'm lazy. Or efficient, depending on how you look at it. Okay, I'll come back to this in just a second. Just kidding. I'll leave it there because you're all writing. Good job. Keep writing. So that goes back to what we just wrote in this last one. Right here, definition congruent. If two segments are congruent, then we know that they are equal. So that's our definition of congruent segments. Definition of congruent angles is that the angles are equal. We did segments though. So definition of congruent segments. All right, now I'm thinking that I have HJ is equal to JK. And we already know what JK is. How much is JK? 15. So instead of when I write this again, not necessarily reverse it. I'm going to keep this HJ, but now I'm going to replace. Instead of saying JK here again, I'm going to replace JK with the amount that it's equal to.
So what does HJ equal to?
15. Because instead of writing JK there again, we knew it was the same as JK, but JK is the same as 15. We switched that out. Now this goes back to Friday. Who remembers what property is that, where we switch something out that it's equal to? Substitution. Good. Just like how if you substitute a teacher, can you substitute anyone in for a teacher?
No.
No. My 7-year-old niece would love to come in. All right, and that's property of, do we do a congruent sign or an equal sign? Equal, so property of equality. My 7-year-old niece would come in here and grab all your cell phones, put you all in the principal's office, Did I tell you guys that? When we were playing school with my niece, I got sent to the principal's office, which was her dad, which is my brother. I got sent to my brother when we were playing school. She's a strict teacher. All right, we have one more that we're going to do here, so make sure you leave room to glue that in. We'll glue it in just a little bit. Again, we're going to color a little bit on this next one, so it's a little bit easier. So I'm going to glue this in just a moment. Oh, just kidding. One last thing. How did I know that I was at the end?
Because we found out the distance between HJ.
Yeah, did it match our conclusion?
Yeah.
Yep, so we knew we were done. Sorry, I got too excited about being done. Yay. All right, we got one more. This one is a lot more steps. This one is about 9 steps, so you do want a good chunk of your page for this one. All right, I'm going to be gluing this one in right here in just a moment. We'll glue it in, but I'm going to just leave it there for a moment. All right, we're going to set up our 2-column proof. All right, so on the left side we have statements, and on the right side, reason. Before I even write my first statement, I could fill in my first reason. What is my first reason always going to end up being? Given. It's always what information were we given in this picture? What information do we know from our hypothesis? All right, this one we are given a lot of information. We're going to color code this as we go, or I'm going to color code it as I go. So if you want to take out, we're going to need 3 colors. I'm going to use green, orange, and yellow, just because that's what's at my fingertips. So if you want to take out some colors, you can. I'm going to use green, orange, and yellow. All right, what's our first statement here? What do we know? What's in that hypothesis that we're assuming is true? Good. Angle FGJ is congruent to angle JGK. So I'm going to color code these so I know which angles we're looking at. So FGJ, F, G, and J. Is congruent to JGK. JGK is this middle one. Alright, I'm color coding to help me visualize, decide what goes with what. Is there anything else we're given? Good. Angle JGK is congruent to angle KGH. That's still in that hypothesis. It's still in the if part. Okay, I already did JGK in yellow, so whatever color you did up here, you could color code it the same as this one. And then KGH. All right, now sometimes I forget that that's not what we're all given. There's more information here. What other information do I know? That's our conclusion. We don't know that yet. That's what we're going to try and prove, is that x equals 2. So that'll be how we end our last statement. Sometimes for the given, we have to look at the diagram and see what information there were we given. And when we're looking at this diagram, we see this x minus 12 and the 7x, right? So I know that angle, the measure of angle FGJ, my green one here, so that measure is equal to x minus 12 degrees. Okay, and I'm color coding that green because that's my green angle there. Oh my goodness, Miss Murrow. And what other angle do we know? Somebody whispered it. KGH. My orange angle is how much? Seven x degrees. So we are actually given 4 pieces of information to start off this proof. Kind of a lot. So eventually we want to come from these congruent symbols into saying that x equals 2 based on these congruent statements and these equal statements, equality statements. So for statement number 2 now, we need to come up with something new that we haven't come up with yet based on that information that we're given. Okay, now if I know that FGJ, this green angle, is congruent to JGK, my yellow, the middle, and that middle is congruent to the right side, what do I know about all 3 of those angles? They're all congruent because this one's the same as this one's the same as this one, so all 3 are the same. Which angles have we not compared yet saying that they are the same? Good. FGJ, that first angle, my green one, whatever color yours is, I don't know, is congruent to the last one, KGH. Okay, so for my reason for that second statement, what said that if this is congruent to that and that is congruent to this, then they're all the same, so I can go with first is the same as last. We just wrote it today, so if you need to go back and look to the beginning of your notes, what theorem or property is that that says this is the same as that? Yeah, transitive. So what you said? You said transitive?
Yes.
Good. Transitive. And is this with an equality, an equal sign, or congruence? Congruence, because we're using a congruent symbol, so property of congruence. Now for step number 3, we might take something back from our given and put it in for 3 for another information that we know. Or we might take it from step number 2 and rewrite something from step 2 that we know. So in step 2, we said 2 angles are congruent. What does that really mean if they're the congruent? They're the same. So let's say that the measures are the same. Measure of angle FGJ is the same or is equal to the measure of angle, KGH. So because they were congruent, we now know that they are equal. What told us that? What part of number 2 told us that we could write that they're equal in number 3.
Oh,
What symbol in number 2 said that if they were congruent, then now they're equal?
congruent sign.
Yeah, the congruent sign. That's our definition of congruent. Now, are we talking about segments or angles? Angles. Definition of congruent angles. All right, now we're kind of past the point of looking at the picture. We can just kind of go based on this information. If you need to look back at the picture, you can. Eventually, we're working towards x equals 2. That's our conclusion. So at some point, you probably want to include those x's, right? Can I include them at this point? I wrote measure of angle FGJ. What do we know measure of angle FGJ was equal to? Good, x minus 12. What do I know the measure of angle KGH is equal to? 7x. We stated that back in our given. We could also look back at that picture. So we're switching out those measurements for what they're equal to in our picture, in our diagram. What do we call that when we switch something out? Substitution. Now, substitution only works with equality. So that's our substitution property of equality. All right, in the end, our conclusion says x equals 2. So our goal is to get x by itself. So now we're going to solve this equation. If I want to solve this equation, what would I do first?
We have to add
What's on?
12
We could add 12.
or minus 7.
Or we could minus x even,
X.
right? Do you guys want to add 12 or minus x?
Minus x.
Minus x, okay. So I see I have an x here, so to get rid of a positive x, we do a minus x. And if we do it on one side,
We do it on the other.
good. That's a property of equality. What was our property of equality there? What did we do to both sides? Minus, subtraction. So once we minus 12 on both sides,
So
I'm sorry, I said that wrong.
7x minus x equals 6x.
Good. If I have 7 x's and I take away an x, I'm left with 6 x's. I took away the x on this left side, so what am I left with on this left side?
Negative 12.
Minus 12 or negative 12. So I don't remember, what do we call that when we actually switch something out for the answer? Rather than rewriting this as 7x minus x or x minus 12 minus x, we made it simpler, we made it easier to work with. Substitution. Now, again, if you're helping someone in another class that maybe they're using ALEX, for some reason their ALEX uses simplify there, but we use substitution as the correct term. ALEX is wrong. We're right. We're smarter than computers. You guys seem really excited about this. All right, number 7. We're still trying to get x by itself, so what's our next step? Divide by what? 6.
X equals negative 2.
Oh, hey, you guys, there was a mistake. Okay, that's okay. So divide by 6, divide by 6. So for number 7, what property is that?
Division.
Division property of
So division property of
equality, because we're keeping both sides equal. So then number 8. Almost done. What's negative 12 divided by 6?
-2.
Negative 2 equals x. What's that property? Substitution. We're switching it out for the answer. Rather than writing out negative 12 divided by 6, we're writing it for the answer. Now, as you can look back at our problem, I'm going to move this problem down so we don't have to move back up. See how this said then x equals negative 2? Do you all see that? See that? AKA, everyone sneak a negative in there. It should say x equals negative 2. Not 2. That was my bad. I forgot to change that. All right, did we get to that conclusion? No. What do I need to do now? What's my last step going to be? I have to make it x equals negative 2. It has to look exactly like our conclusion, exactly like the then. Now, I could do that, though, because based on number 8, step 8 told me in step 9 I can flip it around like that. What property says we can flip it around? Symmetric. All right, we got like 20 seconds left. Just kidding, we have a minute and a half left. All right, if you have time, go ahead and glue those in really quick. You have about 70 seconds to do so. Otherwise, you might lose them.
Can I?
Give me 2 seconds to live. Alright, when we glue quick, you don't even have to worry about squeezing that thing, your dabber. You're just dabbing it on real quick. Making sure that the lid gets back put on all the way, screwed on all the way.